Infleqtion, a neutral atom-based quantum technology company, is partnering with NASA to upgrade the International Space Station using the agency's Northrop Grumman 24 cargo mission. These upgrades could unlock new experimental capabilities with the potential to improve navigation, strengthen Earth monitoring, and support critical infrastructure resilience. Joining me now, Infleqtion CEO Matt Kinsella. Matt, thank you for being here. It's been quite a week for space exploration in general with Artemis. But talk to us about this, in particular, what this partnership means.
Absolutely. Well, first of all, Cheryl, thanks so much for having me. And let me tell you a little bit about Infleqtion, because it will just help inform the answer I gave you about the partnership. So we're a quantum technologies company. We build a suite of quantum products based on these quantum cores. So at the heart of all of our products resides something like this. And inside here reside millions of atoms. And we hit those atoms with lasers to turn the quantum mechanical properties of those atoms into products. And we can build things ranging from clocks to sensors, which in this case is what we're sending up to space with NASA.
Sensors to the ISS.
To computers. And so why does this matter? The sensor that we're sending up into space is replacing a sensor that we put on the ISS in 2018 to help upgrade the research they're doing, because you can actually do much better research on quantum and microgravity of space. But the reason we're doing it is to enable an application. And so the next thing we're doing with NASA is to send what's called a quantum gravity gradiometer into space, which will reside in a satellite with no humans in the loop. So it'll be doing an application, and that application is to sense changes in gravity on the Earth's surface. And you can infer a lot of very interesting things about changes in gravity on the Earth's surface, what's happening both on the surface but also under the surface.
Why is that important, though, to make sure that we monitor that?
Sure.
Whether it's from the ISS or whether it's from a satellite?
So let's use a couple examples. We can monitor the depletion of aquifers, and so we can see if countries are going to go into a drought. And if a country's in a drought, they have a higher probability of some sort of revolution or revolt. We can also see potentially tunnels being dug under the Earth's surface, things that are happening beneath the Earth's surface. Yes, and so when you're doing it from space, you can't precisely see a small area, but you can cover a big swath, and then you can go say, hey, I need to go take a look at what's happening here, and look, more precisely what's happening under the Earth's surface in this particular area. Okay,
so talk about the importance of quantum computing throughout this Iranian conflict. You have a couple of points I want to bring up.
Yes.
You say that GPS interference is now a key tactic in this conflict.
Yes.
And across the Strait of Hormuz, which I think is very important. And that atomic clocks are emerging as one of the few credible countermeasures that we've got, which is what you're talking about, which allows the ships to pass through without retaliation. And then you recently partnered with Safran Electronics and Defense to integrate the ticker quantum optical clock into these mission-critical systems.
That's right.
But talk about how this integrates with the GPS interference.
Sure. So what is GPS? GPS is a cluster of roughly 30 satellites that's circling the Earth, and they're sending a time signal down to Earth's surface. And based on that time signal they're sending, we can infer all the different services that we use GPS for: navigation, synchronization, etc. The problem is that the signal that's being sent is very easy and able to be spoofed or denied. And so what's happening over the Strait of Hormuz is our adversaries are both spoofing and denying that GPS signal. So you either just don't have the access to GPS to navigate, or you think you're somewhere else, or you think your drones are somewhere else. And what we can do is we can provide better than GPS timing and navigation without having to access GPS. So it helps us wean ourselves off of a critical weakness in GPS.
This would protect the ships, but it would also protect our military.
Yes, absolutely. It would be a huge capability for the military, because any conflict we go into, you could almost assume GPS will be denied. And so the ability to have better than GPS communication, navigation, synchronization using quantum sensing would be a massive strategic advantage for whichever side had it.
Your company, you just released financial guidance for the year. Projected $40 million in revenue. That's $32.5 million last year. The quantum technology market is expanding. This I think is fascinating. Look at this. The market reportedly going to grow to $97 billion by 2035 and $168 billion by 2040. This is an investment theme that we've talked about on the network.
It is. If you think about the technology trends that we've been experiencing over the last 50 years, we're in the AI wave right now. I deeply believe quantum will be the next technology wave, and it will integrate with AI and just turbocharge what we can do with technology.
Well, again, from an investment perspective, this is the conversation. The next generation of AI is quantum AI.
That's right.
And that's where the money is going. Matt Kinsella, thank you so much for being with us.
Thanks for having me, Cheryl.